You think you know what light is. You flip a switch, the room gets bright. You see colors, you see shadows, you watch the sunset turn orange and pink. Simple, right? Light is just there. It's the stuff that lets you see. But here's the problem: that's not light. That's just the biological response your eyeballs have to electromagnetic radiation. Most people walk around thinking light is some kind of glowing substance that shoots out of the sun and bounces around until it hits your face. You imagine little particles, like tiny bullets of brightness, zipping through space. Or maybe you learned in school that light is a wave, ripples spreading through space like ripples on a pond. Here's what nobody told you: it's both. And also neither. And the moment you actually try to understand what light is, the entire universe starts to look like a very elaborate practical joke. Let's start with the most obvious thing about light, the thing everyone thinks they understand: speed. Light moves fast. Everyone knows this. 186,000 miles per second. Fast enough to circle the Earth 7 times in 1 second. That's impressive. But here's what's truly bizarre, and this is where your intuition completely fails you. Light always moves at exactly that speed. Always. You're thinking, well, of course. That's its speed. What else would it do? No, you don't understand. I mean always. If you're standing still and you measure light, it goes 186,000 miles per second. If you get in a rocket ship and fly toward the light at half its speed, you'd think the light would appear to be going only half as fast toward you, right? Like if you run towards someone throwing a ball, the ball seems faster. Wrong. Dead wrong. The light is still going exactly 186,000 miles per second in your measurement.
If you turn around and fly away from the light at half the speed of light, you'd think it would catch up to you more slowly. Nope. Still 186,000 miles per second. This is not a mistake. This is not a measurement error. This is the universe telling you that your common sense is completely, utterly, spectacularly broken. The speed of light is the speed limit of the universe, and it's the one number that never changes no matter who's measuring it or how they're moving. This single fact, this one stubborn measurement, destroys everything you thought you knew about how motion works. It's why time slows down when you move fast. It's why nothing can go faster than light. It's why the universe is the way it is. Now let's talk about what light actually is, because this is where things get properly weird. In your everyday life, you understand the difference between a particle and a wave. A rock is a particle. You can hold it, throw it, count rocks. Water waves are waves. They spread out, they ripple, they interfere with each other. These are completely different categories of things. Light refuses to pick a side. Here's an experiment you can actually do, and people have done it thousands of times. Take a barrier with 2 narrow slits cut in it. Shine light through both slits onto a screen behind them. What do you see? You see a pattern of bright and dark bands. This is called an interference pattern, and it's exactly what waves do. When 2 water waves meet, sometimes they add together to make a bigger wave, sometimes they cancel out to make calm water. Light does this too. The light coming through one slit interferes with the light coming through the other slit, creating bands of brightness and darkness. This proves light is a wave. Case closed, right? Not so fast. Now let's turn down the intensity of the light. Way down. So dim that only one photon, one tiny quantum of light, goes through at a time. You'd think that one particle would go through one slit or the other, hit the screen, make a dot, and that's it. You send 1,000 photons through one at a time, and you should get 2 piles of dots, one behind each slit. That's not what happens. Even when you send photons through one at a time, somehow, impossibly, they still create the interference pattern. It's as if each single photon goes through both slits simultaneously, interferes with itself, and then decides where to land based on the wave pattern. A single particle is acting like a wave that splits and recombines. This is not a metaphor. This is not an approximation. This is what actually happens, and it makes no sense in the language of our everyday experience. But wait, it gets worse. Let's say you get clever. You set up detectors at the slits to watch which slit each photon actually goes through. Now you'll catch the photon in the act of its trick. You'll see it go through both slits, right? Wrong. The moment you set up detectors to watch, the photons start behaving like particles. Each one goes through exactly one slit. And the interference pattern disappears. You get two piles of dots, just like you'd expect from particles. The act of measuring which slit the photon goes through changes what the photon does. It's as if light knows you're watching and decides to behave differently. This is not a problem with our equipment. This is not because our detectors are clumsy and disturb the photons. This is fundamental. This is the universe telling you that reality itself is observer-dependent. Richard Feynman, who was probably the greatest physics teacher who ever lived, said this experiment contains the only mystery of quantum mechanics. Everything else weird about quantum physics is just this same weirdness wearing different hats. Let's bring this back to Earth, because I promised you everyday examples. Think about sunglasses. You know they block light, make things darker. Simple. But polarized sunglasses do something much stranger. They only block light that's vibrating in certain directions. Wait, light vibrates? Yes. Light is an electromagnetic wave, which means it's literally a vibrating electric field and a vibrating magnetic field, perpendicular to each other, traveling through space. When light bounces off water or glass at a certain angle, it tends to vibrate mostly in one direction. We call it polarized. Polarized sunglasses have a filter that only lets through light vibrating vertically and blocks light vibrating horizontally. This is why polarized sunglasses are so good at blocking glare from water. The glare is horizontally polarized light bouncing off the surface, and the sunglasses block exactly that. Your brain doesn't know this is happening. Your brain just registers less bright. But what's really happening is that the filter is selectively stopping electromagnetic vibrations oriented the wrong way. Here's where you can do a simple experiment right now if you have two pairs of polarized sunglasses. Look through one pair. You can see fine. Now hold the second pair in front of the first, both lenses aligned the same way. Still fine, just darker. Now rotate the second pair 90 degrees. Suddenly, almost no light gets through. Everything goes black. Why? The first pair of sunglasses only lets through vertically vibrating light. The second pair, now rotated, only lets through horizontally vibrating light. But there is no horizontally vibrating light left after the first pair blocked it all. Result: darkness. This simple demonstration proves that light is a wave with a direction of vibration. You can test wave mechanics with $20 sunglasses. The universe is revealing its secrets in your hands, and most people never notice. Now let's talk about color, because you definitely think you understand color. Red light, blue light, green light. Different colors are just different kinds of light, right? Well, yes, but what makes them different? The only difference between red light and blue light is how fast the wave vibrates. That's it. That's the only distinction. Red light vibrates about 430 trillion times per second. Blue light vibrates about 670 trillion times per second. Your eye has 3 types of cone cells that respond differently to different vibration frequencies, and your brain interprets those signals as color. This is why polarized sunglasses are so good at blocking glare from water. The glare is horizontally polarized light bouncing off the surface, and the sunglasses block exactly that. Your brain doesn't know this is happening. Your brain just registers less bright. But what's really happening is that the filter is selectively stopping electromagnetic vibrations oriented the wrong way. Here's where you can do a simple experiment right now if you have 2 pairs of polarized sunglasses. Look through one pair. You can see fine. Now hold the second pair in front of the first, both lenses aligned the same way. Still fine, just darker. Now rotate the second pair 90 degrees. Suddenly, almost no light gets through. Everything goes black. Why? The first pair of sunglasses only lets through vertically vibrating light. The second pair, now rotated, only lets through horizontally vibrating light. But there is no horizontally vibrating light left after the first pair blocked it all. Result: darkness. This simple demonstration proves that light is a wave with a direction of vibration. You can test wave mechanics with $20 sunglasses. The universe is revealing its secrets in your hands, and most people never notice. Now let's talk about color, because you definitely think you understand color. Red light, blue light, green light. Different colors are just different kinds of light, right? Well, yes, but what makes them different? The only difference between red light and blue light is how fast the wave vibrates. That's it. That's the only distinction. Red light vibrates about 430 trillion times per second. Blue light vibrates about 670 trillion times per second. Your eye has 3 types of cone cells that respond differently to different vibration frequencies, and your brain interprets those signals as color. Every photon that has ever existed, from every star in every galaxy, experiences its entire existence as a single instantaneous flash of being. This is what relativity does to light. It removes time from the equation entirely. Now let's talk about what happens when light tries to go through stuff. You know that light slows down in water and glass. That's why lenses work. That's why you can see a bent straw in a glass of water. But do you know why light slows down? It doesn't. Not really. The speed of light in vacuum is always 186,000 miles per second, and light always travels at that speed. Always. So what's happening when light slows down in glass? Here's the real mechanism: when light enters glass, it hits atoms. The electromagnetic wave of the light shakes the electrons in those atoms. Those shaking electrons emit their own electromagnetic waves. The original light wave and all these new waves from the electrons combine together. When they combine, they create a pattern that looks like a slower wave moving through the material. But the actual light, the actual photons, are still moving at full speed in the tiny spaces between atoms. The apparent slowing is an interference effect caused by billions of tiny delays as electrons absorb and re-emit photons. It's not that light slows down. It's that light takes a very complicated path through a forest of atoms, and the overall result looks slower. This is why different colors of light slow down by different amounts in glass. Blue light makes the electrons vibrate differently than red light. Different vibrations, different interference patterns, different apparent speeds. That's why a prism splits white light into a rainbow. It's all because of how electromagnetic waves interact with clouds of electrons. Here's one more everyday thing that's secretly bizarre: shadows. You think a shadow is just the absence of light. Light goes in straight lines, an object blocks it, dark spot appears behind the object. Simple geometry. Except light doesn't go in straight lines. Light goes in every possible path simultaneously, and the paths interfere with each other. Most paths cancel out due to interference, and what's left over looks like a straight line. But near edges, near boundaries, the interference pattern becomes visible. If you look very carefully at the shadow of a sharp edge, you'll see faint bands of light and dark near the boundary. This is called diffraction. It's the same interference effect we saw with the two slits. Light bends around corners, just barely, because light is a wave and waves do that. This is why if you make the hole through which light passes small enough, the shadow gets blurry. The light waves spread out after passing through the tiny opening. This is fundamental. You can't make a perfectly sharp beam of light by making your hole smaller, because once the hole gets down near the wavelength of light, the wave nature takes over and spreads the beam out. Every shadow you've ever seen is lying to you about the straight-line nature of light. The lie is close to the truth, but it's still a lie. So what is light? It's a self-propagating electromagnetic wave. It's a particle with zero mass that somehow still carries momentum. It's the fastest thing possible. It's the messenger that tells atoms about other atoms. It's the only thing you've ever directly perceived, because you don't see objects, you see light bouncing off objects. Light is also the reason you can't go faster than light. As you accelerate closer to light speed, you gain energy. That energy has mass, even though you're not gaining atoms. The faster you go, the heavier you get, the harder it is to go faster. To actually reach light speed would require infinite energy, which doesn't exist. Only light can travel at light speed because only light has zero rest mass. This means the universe has a speed limit built into its operating system, and that speed limit is light. The maximum speed of cause and effect. The maximum speed of information. Nothing can go faster because if it did, effects could precede causes, and the logic of reality would break down. Richard Feynman liked to say that light is a naked charge, a photon is just the electromagnetic field itself, vibrating in a self-sustaining pattern. There's no little ball, no substance, just field. Pure field. A photon is what the field does when it moves. This is desperately unsatisfying to human intuition because we want light to be made of something. But it's not made of anything. It is something. The field is the thing itself. When people first figured this out, they were so uncomfortable with the idea of a wave traveling through nothing that they invented an invisible substance called the ether that filled all of space. Light waves were ripples in the ether, they said. Just like sound waves need air to travel through, light needs ether. Then we measured it. We did incredibly clever experiments to detect the ether, to measure how fast the Earth was moving through it. We found nothing. The ether doesn't exist. Light needs no medium. Light travels through empty space just fine because light is a disturbance in a field that exists everywhere always. This is profoundly strange. You're sitting in a room right now. That room feels empty. It's not. Every cubic inch of empty space is filled with electromagnetic field, gravitational field, quantum fields for every type of particle. The fields are reality. The particles are just excitations of the fields. Light is the electromagnetic field waving. So when you flip a light switch, you're not creating light and sending it across the room. You're exciting the electromagnetic field in the filament or LED, and that excitation propagates through the field that already fills the room, and that propagating excitation is what we call light. The universe is a collection of fields, and everything you've ever seen, touched, or measured is just those fields vibrating in complicated patterns. Light is one of the simplest patterns, which is why we can understand it at all. But even this simple pattern destroys our intuitive picture of reality. Here's the final twist, and this is where we get back to that two-slit experiment that started this whole mess. When a photon goes through both slits and interferes with itself, it's not really going through both slits. The wave function is going through both slits. The photon is the wave function collapsing into a definite position when it hits the screen. Before the measurement, the photon is nowhere. It's not secretly at one slit or the other. It genuinely exists as a spread-out wave of probability covering both slits simultaneously. When you detect it, you force it to choose. The act of measurement converts possibility into actuality. This means reality is not made of things. Reality is made of probability waves that collapse into things when observed. Light is teaching us that the universe at its foundation is not concrete objects moving through space. It's mathematical patterns of likelihood that crystallize into concrete reality through interaction. This is why Feynman said the two-slit experiment contains the only mystery. Because it reveals that nature is not what we think it is. Objects are not what we think they are. Even asking, "What is light really?" might be the wrong question. Light is what happens when we poke the universe with our measuring devices and the universe pokes back. Every time you turn on a lamp, you're creating a trillion photons per second. Each one is a quantum of electromagnetic field. Each one travels at the universe's speed limit. Each one carries energy and momentum despite having no mass. Each one takes every possible path to your eye simultaneously. Each one exists as a wave until measured as a particle. And your brain takes this incomprehensible quantum mechanical miracle and reduces it to bright. That's not light. That's just your translation scheme. Light is so much stranger, so much more fundamental, so much more impossible than your everyday experience suggests. And the fact that we figured this out, that we can predict how light behaves down to 1 part in a billion, using math that describes fields and waves and particles all at once, that's the real miracle. You flip a switch. Light appears. You think you understand. You don't. Nobody does, not really. We just have equations that work. And those equations tell us we live in a universe where light is always watching, always moving, always revealing that reality is not what it seems. That's light. Now you know you don't know what it is. That's progress.